Hi, this is Marco Valeri. I am working as a solution engineer for Oracle, and I have with me today the product manager of ZFS storage system, Cindy Zweringen.
Hi, Marco. I'm happy to be here today. Thank you for inviting me.
We have quite an interesting topic today. Backup and restore are not the most loved operation in the data center, yet they are the most frequently performed task. So, how can ZFS help our customer on Oracle database backup and restores?
Well, it's no secret that ZFS offers the industry's fastest backup and restore performance, with some customers achieving up to 60 terabytes an hour for restores. But that is not the best we can do. The best backup and restore is the one that you can avoid altogether. ZFS can help you avoid full backups and restores for several common scenarios.
Even when done once in a week, running a full backup is always an issue. So how can we avoid it with ZFS?
What we do is we combine incremental RMAN merge with ZFS snapshots. For example, after the full first backup, T0, we take an incremental every day and merge it with a full backup. Next, we take a ZFS snapshot to preserve the full backup. This means that we only need to do incremental backups that includes a smaller set of changes.
Now I understand how full backups can be avoided. But how are we going to avoid the restores?
Good question. With incremental merge, we end up with a full backup image inside a ZFS snapshot. With a process called CloneDB, we can create a database instance or many database instances from this base image without a restore. And we can do it very quickly. Naturally, we keep the base image intact, and we only need additional capacity for changes that are generated by the database clones.
So we will have DB instances created out of backup images without restores. Combined with incremental merge on ZFS, this functionality can totally change the way our customers perform backup and restore. But I wonder how complex is this?
Let me show you.
Here we start the incremental merge process. Our script will run us through all the stages. We start with the incremental backup. That is going to take significantly less space and time than a full backup. We support deduplication with ZFS, but this is far more efficient than any deduplication on any storage and doesn't have the penalties. Now we will do the RMAN merge to have an up-to-date full image backup. Okay, that was quick. Now we need to back up the control file and the archive logs. This is all scripted, so I'm not doing much work. Every day's full image backup is stored as snapshots on ZFS, consuming very little space. As you can see, the latest snap is from the 8th of July. We are clearing the archive logs. Now we will create the ZFS snapshot to freeze this full backup image. Here we see the snapshot created on ZFS. Very little space is used compared to a full backup.
Amazing! This can certainly help with backup windows and storage efficiency issue. How about the CloneDB functionality? Is also this simple?
Yes, let's continue with the demo then.
Now we will create a clone database from an image backup without restoring. The script reads the available snapshot and asks which one we want to use as our base image, and we will be using the last one we created. We see new snap clone shares are created on ZFS to host the database, consuming almost no space. These clones are actually writable snapshots. We catalog the logs so we can use them to recover the database before opening. Initial full backup will consume some storage, but each additional day will require only changes stored, and each clone we create will also require minimal additional storage. Now we only need recovery. No restore is needed. We are using clones on the ZFS, which is a writable copy of a snapshot. It uses very little storage, and we also keep the base backup image intact in the read-only snapshot. Looks like recovery is finished. Let's export with a unique SID. And finally, here we have our space-efficient clone database. Almost instantly, we can create as many clones as we want.
Wow, so we can create up and running DBs from backup images without restarting them. What are the possible use cases?
Well, deploying dev and test environments is the obvious use case. We also see several customers using it for partial restores. Another use case is emergency restores where you don't have the time nor the space to do a full restore. You can also use this technology to validate backups quickly. I think at the end of the day, we can avoid 90% of actual restores.
What is the hidden catch?
Well, we need to use RAID 10, but thanks to the ZFS hybrid storage pool architecture, we can leverage inexpensive 14 or 18 terabyte drives. When you combine this with the extra storage efficiency that we gain with using incremental merge, and by not using additional capacity for clones, we end up with a solution that is highly optimized for efficiency.
Thank you very much, Cindy. This is a brilliant solution to tackle performance, backup window, and capacity utilization problems. Now, let's take a look at how one of our customers is utilizing this function in their environments.
Yes, let's watch.
Hi everyone, greetings from Turkey. My name is Mehmet Sülün. I have 14 years of IT experience, mostly evolving around database technologies, and at the moment I am leading database team at Energy Exchange company for Turkey. EPH is a relatively young company established to plan, develop, and manage energy markets by providing efficiency, transparency, and reliability. Although we are quite young, with scientific growth year after year, now EPH is at the top of the Fortune 500 list for Turkey. Operating in a highly dynamic energy sector as a market maker, EPH has to continuously innovate new products, service around the globe. Our challenges are not much different from other companies in a similar market. One of the things that stressed us was data protection. We need to satisfy backup and restore goals, but our database size was growing exponentially. So we had to figure out a way that would be less affected by the data growth. Also, longer backups means we are keeping system busy, forcing us to upgrade them frequently or face some performance issues. And we know that longer backups also means restores which a risk, and we didn't want to carry. Being relatively young, we had a lot to catch up to satisfy our goal of matching an existing world standards in our market. Naturally, we were faced with the need to quickly deploy new services that required us to deploy full-size development and test instances as fast as possible, and creating even a single copy of a large database, 15 or 100 terabyte, is not really easy. It takes time and lots of resources like additional storage and deployment workflow may require several people from different teams to be involved. Now multiply this with several copies, we had to deploy, maintenance, refresh, and archive their life cycles. Things get complex very quickly. Let's take a brief look at our infrastructure for Oracle databases. First of all, data is everything to us, so we employ both local and remote replication for our critical databases. And we also make sure that we have backups available on both sides. We have consolidated our databases on Oracle engineered systems, Exadata systems namely. We also have two ZFS storage systems, one at each site, connected to Exadata systems. As we are utilizing Infinibat-based Exadata systems, we utilize Infinibat between ZFS and Exadata systems, which helps with the performance and is also let us keeping things simple. Our backups head to ZFS over the Infinibat links. However, instead of taking full backups every day, that will take a lots of time, or making compromise and rely on full plus incremental backups. We use forever incremental backups on ZFS systems. I will share more details on this process on the next slide, but I need to emphasize backups takes a lot less time and capacity once the backups are on ZFS. With the CloneDB technology, almost instantly compared to what we have previously, we can deploy clone systems. Best of all this requires almost no additional capacity. ZFS's ability to function both as a backup disk and a regular storage really help us here. As I mentioned shortly in this previous, instead of taking a full backup, we utilize incremental merge technique combined with ZFS snapshot. Basically, every day we can take an incremental backup, merge it, freeze it in a snapshot. This way our backup times are significantly reduced, and this is in line with the storage capacity we need. But we didn't give up from security of having full backup images of every day. And we have experienced it that while the DB size grow quite rapidly, as no one likes to delete any data, daily changes data amount is increased at a slower pace. And as we only take incremental backups daily, our backup times are more or less stable. We utilize image backups for data protection, and one great advantage is by utilizing clone database functionality on ZFS, we can deploy additional database instance by cloning these images. These images are already frozen in read-only ZFS snapshots, and we make sure that they are not altered in any way. ZFS can create additional read-write snapshots, snap clones, and that is what we are using when deploying these additional copies. It is possible to create multiple copies from a single base image, and very little additional storage is required for each copy, and it's possible to create a snapshot of clone. When we need it, we can create development branches from each arm. These clones can be used for testing, developing, reproduction, and also for quickly restoring a small part of database that is lost or corrupted due to human error. Prior to using ZFS, we had tested restoring a DB from another application to create additional copies. That process took 24 hours, which is not acceptable, and when we tried the same process on ZFS using CloneDB, we were able to reduce time to half an hour, almost 50 times improvement. And as a bonus, we didn't need extra storage area to restore, as we are not restoring. By the way, ZFS is very tunable and it's quite easy to tune. So while we can tune some of the shares for maximum backup and restore speed, we are able to tune clone share for random IO maximize performance. Despite the fact that we open many database instances from ZFS simultaneously, it looks like this storage can take some load easily. Beyond the backups and deploying clone databases for development and test cases, we also use ZFS for testing before upgrading. Our databases are shared across many applications, which makes upgrading database quite challenging for us. It's very critical. So for example, on 11G to 12C upgrade history, we tested upgrade 20 times or more. ZFS gave us the chance to make tests in parallel, since we can deploy several copies without any extra storage required. This is why it's quite valuable for us. I hope that our experience in solving some of the problems we face every day can help you too. And I am aware that these webinars or event over internet is not going anywhere. I am looking forward to time where all we have a chance to physically meet and share experience face to face. Thank you very much.